This lecture is going to cover 1A, which covers isotopes. By the end, you will be able to define atomic number, mass number, and isotope, as well as determine the number of protons, neutrons, and electrons for any element. Now, before we get started, I want you to get out a periodic table. You will be using this a lot today as you go through the lecture and as you work on practice problems. So go ahead and pause if you need to go grab that and come back when you've got it. So elements are made up of three things: protons, neutrons, and electrons. So one of the objectives was for you to be able to determine how many of each of those there are in any element. But before we do that, I want to talk about a few things. So protons and neutrons are going to be found in the nucleus. So similar to your nucleus inside of a cell, it's found in the middle. It's the biggest part. Same thing here in an element. Your electrons can be found outside of the nucleus. Some are close, some are far away, but they are found outside. Some notation that I want you to be familiar with as well is you can see protons written as P+, and that is because protons have a positive charge. Electrons are sometimes written as E negative, and that is because electrons have a negative charge. And neutrons are written as N with a 0, and that is because neutrons are neutral or have no charge. So it's important that you're able to distinguish these by this notation, but that you're also remembering what the charges are, because that will come into play later. If you're looking at your periodic table, you'll see a lot of information is within each box, and I want to talk about what that information is. So the atomic number will be a whole number, and it is going to be at the top of the box. So you can see that here for oxygen, that atomic number is 8. When we talked about elements, we talked about learning elements of a certain number. This is the number that's referring to. So for your first element quiz, you have to learn elements 1 through 36. So you're learning the symbols and the names for the elements that have an atomic number of 1 through 36. The next thing you'll see is the chemical symbol. So for oxygen, that's O. Then on your periodic tables, you will see the element name. However, not every periodic table does have the element name on it. Some of them just have symbols. So another reason in which we need to make sure that we know what the symbols are and what the name is that match. Then the last number you're going to see is going to have a decimal. This is the average mass number. Now, notice that this is the average mass and not the mass number. Those are two different things, and you'll want to make sure that you are able to distinguish between the two. So how do I determine how many there are of protons, neutrons, and electrons? So a few rules, a few things that we need to keep in mind. To find protons, you will use the atomic number. So if you can find the atomic number for an element on the periodic table, then you know how many protons it has. So oxygen, if we look back at the slide before this, oxygen has an atomic number of 8. So oxygen has 8 protons. Fluorine has an atomic number of 9, so fluorine has 9 protons. The key here is if you change the number of protons, you change the element. So just with that oxygen example, if I added a proton, I no longer have oxygen, I now have fluorine. So the atomic number and the protons are going to tell you what element you have. So I could say I have 10 protons, what element am I? I could go to my periodic table, find what has 10. Neon has 10 protons, or 10 as its atomic number, so I know the element is neon. So proton, atomic number, all of that matches the element. If one of those changes, they all change. In a neutral atom, our protons and electrons are equal. So if you remember the slide before that, protons have a positive charge, electrons have a negative charge. When I have a positive and a negative that are the same, overall, I don't have a charge. So beryllium has an atomic number of 4, which means it would have 4 protons plus 4, 4 electrons minus 4, positive 4 plus negative 4 equals 0. So this idea of being neutral here, what I want you to, so right now, neutral, we are going to assume that all of the elements that we are looking at right now are neutral. We will get to it later on when they are not neutral, but for right now, everything is neutral. So our neutrons will have to be determined using the mass number. This is not the average mass that you have on your periodic table. So I'll say that one more time. Your neutrons have to be determined using a mass number that is not the average mass that's found on your periodic table. So that mass number has to be given to you in some way. And we'll look at a few examples here so you can see the different ways that you can see that. All right, so taking a look at what the mass number actually is. So the mass number is going to be equal to the protons plus the neutrons. So if I add those two together, it will give me my mass number. You'll see some notation for mass number in several different ways. I want to show you all of them, but they all give us the same information. So I could give you the entire name of the element dash a number. The number after that, so the 13 in this situation, that 13 means that's the mass number. It could be written as this with the symbol for carbon, which is a capital C, dash 13. That 13 is the mass number. It could be written like this with the 13 as an exponent at the front. That 13 is the mass number. Or it could be written like this, 13 at the top, 6 at the bottom, and your symbol. So 6 in this situation is your atomic number. 13 is your mass number. So here's some examples that we're going to do. So we'll do the first, I'm going to do the first one for you, and then you'll have a chance to do the other ones on your own. So determine the number of protons, neutrons, and electrons in each of the following elements. So my first one is chlorine 34. What I always find to be easiest to do is to use to find the protons, because we know the element, so we can find the atomic number and we can find the protons from there. So if I'm looking at my periodic table, I will find chlorine. It is on the right-hand side. And I will see that the atomic number for chlorine is 17, which means that I have 17 protons. I also know that my protons and my electrons are equal because my element is neutral. So if I have 17 protons, I'm also going to have 17 electrons. The other thing that I want to remember is my mass equals P plus N. So here's where we're going to do a little bit of algebra. So 34 here is my mass. So 34 equals P plus N. P is 17, so 17 plus N. Now I want to solve for N, subtract 17 from each side, which is going to give me 17. So 17 equals N. So I also have 17 neutrons. This will not always be the case, so I do not want you to get in the habit of if there's 17 protons, there's 17 electrons, there's 17 neutrons. You will run into situations where this is going to be true, but it's not going to be all the time. Okay, so don't just assume that your protons, neutrons, and electrons are always going to be equal. All right, so your next one is aluminum 26. So I'm going to give you a chance to try this one on your own, but just a reminder here is that this number right here, the 26 that's underlined in pink, that is your mass number. Okay, so go ahead and pause the video and give that one a shot on your own. All right, so let's see how we did. So remember that aluminum is going to be defined by its atomic number, which also equals my protons. So if I look at my periodic table and I find aluminum, which is a capital A, lowercase l, I will see that my protons, or my atomic number, is 13. I know that my protons and my electrons are going to be equal. So if one is 13, the other one is 13. And now I have to determine my neutrons. So once again, I'm going to use this equation up here. My mass number equals my protons plus my neutrons. So 26 equals 13 plus n. Subtract 13 from each side. N equals 13. So once again, I told you not every example is going to have equal numbers, protons, neutrons, and electrons, but this one here did. And one more example, give this one a shot on your own. So go ahead and pause, see if you can do that one on your own, and then come back. All right, so I did not remind you, but hopefully you remember that this 27 means that that is my mass number. So once again, always start with those protons. That's usually the easiest place to start. So I'm going to look at my atomic number. Once again, I know my atomic number for aluminum is 13. So there's a 13 here. It's neutral. So my protons plus my electron, or my protons and my electrons, are going to be equal. And now for my neutrons. So if I go back up to my equation up here, mass equals P plus N. So 27, we'll do it up here, 27 equals, that should be a 13, right? 13 plus N. So if I subtract 13 from each side, my N is going to be 14. So in this situation, I have 14 neutrons, whereas before I had 13. So that difference in mass number is going to give you a difference in neutrons. All right, so we'll clear all this off here. And then we have one more thing to talk about. All right, so the last thing that we want to look at are what isotopes are. So that's the last definition that we need. You've already looked at an isotope and you haven't even realized it. So an isotope is going to be the same element with different number of neutrons. So look at the examples we just did. We had aluminum that had 13 neutrons, and we had aluminum that had 14 neutrons. But both of them were aluminum. So that is the key here, that you have the same element, but you have different number of neutrons. So I can have an isotope of carbon where it might have 6 neutrons, and I can have another isotope of carbon that might have 7 neutrons. Same element, different number of neutrons. So here's a key on this, and we hit on this already a little bit, but that the number of protons cannot be changed. If I change my protons, I change my element. Later on, we'll be changing electrons, so know that those can change, but right now they're equal to your protons, but they can change. Your neutrons can change because that gives us an isotope, but when I change my protons, I change the element. So back to that average mass number that we looked at towards the beginning. So most elements found in nature. So let's just talk about carbon to start with. So all the carbon in nature is a mixture of several different isotopes of carbon. So carbon 11, carbon 12, carbon 13, carbon 14. So carbon with those different mass numbers. And that number that you see on the periodic table is the average of all of the carbon. So it's the average of the carbon 11s, the 12s, the 13s, and the 14s. So that's why we don't want to use that number, because it's an average. We want to know the exact number for that specific isotope that we are talking about. So you do have some practice problems to work on. And as always, please let me know if you have any questions, if you need any help, and good luck.